con Guillermo Piñeiro, que es un técnico especialista, y quién va a ser la persona que a continuación va a hablarnos acerca de uno de los equipos que particularmente tienen una importancia para nuestro grupo de investigación, y es el analizador de emisiones portable, el PEMS. Y encontramos que tener un poco más de información, un poco más de datos de primera mano de Guillermo es de mucho valor agregado para nuestro grupo de investigación. De modo que, sin más preámbulo, Guillermo, por favor, si puedes iniciar con tu presentación.
Ok, entonces agradezco pela introducción y también por esta invitación, pero como puede ver, yo no hablo muy bien español, entonces tendré que hacer esta presentación en inglés. ¿Está bien? So, ladies and gentlemen, hello. First, I'd like to thank Professor Paul for the invitation to join the seminar and share a little bit what we as AVL are working on regarding real drive emissions, what is our experience, and how we can support you through these new challenges. So, let me introduce myself. My name is Guilherme Pinheiro. I studied mechanical engineer and started my professional career in 2014. In 2017, I joined AVL South America as a technical sales specialist in the instrumentation department with the focus on advanced combustion analysis. And since then, I'm also responsible for other segments, which include PEMS and virtualization solutions for powertrain calibration. So today, I will lead you through the real drive emissions topic, starting with a short introduction of AVL, covering the background, because I think this is really important to understand the background as a drive for these new policies in terms of emissions legislation. Then, of course, I will talk to you about the challenges RDE brings with it and how RDE methodology works. And finally, we will also talk about what AVL in this respect can offer before we end this presentation with a conclusion and a Q&A session. Let's start it quickly with some information about AVL. AVL has a professor as its founder, so research is built in our DNA. It's the world's largest independent company focused on development of solutions for the mobility area, from pressure sensors to the test band, simulation software, and engineering service, as well as new fields like ADAS, autonomous drive, and data intelligence. We are involved in more than 1,500 engine development projects and more than 4,000 engine test beds. In addition, we have some basic data from the company that shows AVL's DNA a little. So we have more than 11,000 employees around the world. And one thing I always like to highlight is that 10% of companies' turnover in-house is always directed to research and development. As you can see, for the amount of the patents which AVL owns it. So more than 70 years of experience in the market, working together with our customers, but not only as an equipment and a solution supplier, but seeing our customers as partners. Okay, with that thing being said, let's dive into our RDE topic. So what is the background? Why real drive emissions is needed? The background, namely, is air pollution and human health. There's a lot of discussions about it regarding generating more policies, legislation, or adding burdens to the stakeholders. But there is a real reason why we are here, discuss about RDE and what RDE brings with it in terms of challenges. And we also need to think about what RDE brings in terms of effects, in terms of air pollution or lowering air pollution, improving human health. In the lower left, you can see a chart of São Paulo metropolitan area, showing the number of days each year that ozone overcomes the standards. And another example in these slides is this video that you can see is a time lapse of Beijing Center during morning, showing how the smog covers everything in around 20 minutes. So we can see through this video that pollution is a really important topic. And I don't want to bother you, but there's another chart that contains a particle matter concentration of annual average of few Brazilian cities. Sorry, I skipped the chart. So this is the chart showing again how high in comparison of the World Health Organization recommendation we are. We know that traffic and transport is not only the contributor, of course, but it's only one of the major contributors among industry, among power generation. But in general, we can say traffic and transport is accountable for roughly 1/3 of those emissions which harm us in today's world. So what have these facts triggered into legislation level? These figures and statistics have not started yet for now. It has been monitored for a long while. There's a long history of tailpipe emissions legislations for cars, as we are talking about RDE. Mainly, we are talking about vehicles and cars when I talk about RDE. And the finding over years was basically the emissions limit could not be reproduced on the road, on the real environment. If we look back to the Euro 3, which was implemented in 2000, the gap between laboratory and street level was around 100%. And over the years, the gap percentage was increasing drastically. So what we can see through these years is that the laboratory emissions limits was legislation by legislation decreasing over the years, but the limits found on the road was not following this reduction. The reason behind that basically is every player on this, if you come up with a certain testing cycle, can adapt the calibration towards the test cycle, not looking into the real road. This was the root cause of the Dieselgate, but I will not go deep in details. So, as we discussed earlier, the objective of legislation involving RDE is basically to reduce the level of emission in vehicles under real operating conditions. For this, the vehicle goes through entire certification process in the laboratory and then goes on the street with the portable emissions measurement system, as known as PEMS, making it possible to compare the laboratory limits with those found at street level. When we talk about real operating conditions, we talk about randomness. Traffic conditions vary without warning. The driving mode varies from driver to driver. Temperature variation in the most varied environments, so the equipment needs to be robust enough to withstand measurements in extreme conditions, as well as variation in altitudes, which influence the measurements. So this slide here, in the last 5 years, there has been developing very quickly, where the main markets have already announced the inclusion of RDE in their approval process, which making the necessary adaptations to reflect the particularities of each country. On this slide, it's possible to check the status of the main markets in this direction. So, however, the execution of RDE tests have some challenges to consider. It starts with the test itself. We are leaving a totally controlled environment, which would be the test bench, and going to the street. We will face curves, slopes, temperature, humidity, variation, wind, drive conditions of the driver who may be more or less aggressive on the day of the test, I don't know, or influences from the other vehicles, such as traffic and aerodynamic drag. To have an idea of the impact of some of these factors, we have to have some examples, which shows, for example, the use of the engine map area in the RD test compared to the traditional cycles, the impact of the driver's aggressiveness during the test for PN and NOx, and also the effect of cold start or altitude level. Under that, we also have operational challenges to perform a valid RD test, such as planning a route which will fulfill the requirements plus alternative routes, test costs, including insurance, transportation, manpower, prototypes, climatic conditions, where we cannot control, for example, a test under 15 degrees, traffic conditions. This is the importance to have alternative routes And reproducibility, if we encounter a problem in the test and it's not possible to replicate exactly the same condition. So what AVL can offer to you to go through these challenges? Basically, we have two solutions. One is more focused on heavy vehicles, heavy-duty vehicles, another for light vehicles, passenger cars, but there's clearly an overlap between the two equipments, making it possible to have equipment for both applications. I just want to highlight here that we have more than 700 units sold globally, being market leaders, supplying several OEMs and research institutes. And as information recently, CARB in the United States acquired 10 units for its new research laboratory that will be 100% AVL. So this is when I was talking about to overlap some equipments. So you see here, we have the Move IS Plus with the focus to light duty vehicles, and we have the Move IX for heavy duty vehicles. So when you compare both equipments for light duty applications, the only thing you need to consider is if you use the heavy duty version, you need to spend more effort regarding installation, and also you need to think about the weight. When we are talking about heavy duty vehicles, we don't need to care about weight or dimensions. So this is the reason we have an equipment which is smaller and lighter, focus on this kind of application in passenger cars and light duty vehicles. And what do we think about development? Our solution is very flexible, where we can integrate several modules for other analysis, such as fuel consumption. As you can see, the AVL shown here on the left corner of the screen. Suit in real time with the microsuit sensor of AVL, combustion and power analysis. With this, we have the system control, which will be, so just to explain, we have the modules on the left with these light blue squares. And also we have the system control within the center of our screen is the computer that will be in vehicle, and we will integrate all the modules. After the test, we have a post-process software, which will run the test and do the post-processing analysis, generating the reports. And also we can use this data to go to from load to lab, and also use tools to manage our data from the tests. Just to highlight here also, we have the certification from the TÜV, as our calculations are fulfilling all the requirements from the legislation. Just for your information here, just a price estimation. We have a price estimation of the complete Euro legislative package, including gas PAMs, PN PAMs is the particle number, or the module of flame ionized disflamer is for measuring the THC and CH4, plus the exhaust flow meter software and commission tutorial around 250,000 euro. And this equipment being released in our headquarters in Austria. So in this screen now, you see a test. Another example of the extreme condition. Extreme condition that we did. So here was varying the temperature and also the relative humidity to show the stability of our measurements. So you can see the curves now from NO, CO2, and CO, then stay inside of the tolerances. Here, just an example. Just an example that we did a test in India from our affiliates in AVL India. So we know that India has really high temperatures. We know the chaotic conditions of the traffic, and the equipment would perform really well. You see now, I'm going to show you now just a video. How was the test? So you can see here, the temperature, the ambient temperature was above our limits, but this didn't stop to have a valid test drive. The only problem we have here was with the cellular, the mobile phone from one of our employees, that the temperature was too high, and we saw this warning. So here, just another altitude test, showing that our equipment can operate in extreme conditions, and take the opportunity to emphasize that our equipment is the only one in the market suitable for measurements up to 3,000 meters in altitude. So in each RDE test, this is carried out. It's necessary to carry out a test before and after the main test in order to prove that the equipment operated within the limits required by law, by legislation. And here you can see some examples of these certificates. Just to make, just for information of you, all the certifications I can share with you later, and you can see by yourselves, from yourselves. And here is the live monitor that will help during the test to meet all the requirements for a valid test and guarantee its reproducibility. So AVL Concerto is our software of data post-processing. And we have this data to box called Move for making all the post-processing data of all the RDE analysis. So it's a post-processing tool for different applications and legislations. An example of what we can see from the software would be to correlate instantaneous measurements with GPS data, being possible to investigate where you had some peak emission, in addition to being able to synchronize with a video in order to be able to evaluate in their work environment, in the office, what influenced the results. So here it shows that we are certified by TÜV, proving our evaluation method fulfills the requirements of the legislation. Now this is one test we did when we started these discussions here in Brazil. So we are using a vehicle from our fleet. So we didn't prepare anything from the vehicle before doing the test, just simple install the equipment and went for the trial. So you can see down in this table, you can see the emissions of NOx, CO, CO2. We didn't have a particle number counter, so we don't have this kind of data. And we were evaluated regarding calibration of the gases, hot start trip requirements, dynamic requirements, and using the method of evaluation of MROAD, which now is the current method of evaluation of the RDE. So see, here's the map of the test. So all the GPS data we can see through here. So in these light green lines, you can see which path we choose. And here in the chart below, you can see the speed variation through the time. And this is one of the pages of the report showing that we fulfill the shares of distance, the distance shares regarding urban, rural, and motorway areas, speed, and also regarding the CO2 windows. So after we went through the scenario of performing the test, the work has not yet been completed. You can use the data generated by the test to do studies in the other environments, chassis dyno, engine, powertrain test bed, or even to bring this data to the virtual environment. And AVL offers in all these stages the same models, the same databases, so that you can move between these environments with less effort. And the question certainly arises is, if it's real drive emissions, why do I need to go back to the lab? And the answer is reproducibility. So considering that you have a defined route, so you will inevitably have a variation of the results. due to all the points already shown. However, if any possible problem appears, it's necessary to look in detail at the point of operation or the moment of failure. For this, we can choose a test and we can bring to the lab, and you can run over and over again this test in our chassis dyno or powertrain or engine test bed. So we can try to go a little bit deeper of the investigation. And after done this, we can check the influences and variations regarding temperature, regarding altitude, regarding how is the driver driving the vehicle, is too aggressive or too soft, the engine load, and without the support of your laboratory environment. So this is how we start the workflow, just to show a little example of what we discussed in the slide before. So we do the emission test. We do the PEMS validation. We go for the RDE test. We check the drift. We perform the report. So the typical test of RDE development on chassis dyno. So we go back. We generate this data from the test. We take this data and went to the lab to regenerate these files, this data, to our chassis dyno, and we can rerun the test and do the post-processing again. And also we can do any times we want it, so we can check, we can compare all these reports with the test done in our lab. Before to start, we are reaching at the end of my presentation. I just want to show you in this short video how it works, this process from the RD test done on the street to going to our laboratory. So, for the conclusion of this presentation, RDE is a random, not reproducible test with infinitely many variables. RDE development needs reproducibility, therefore the road test must be transferred to laboratories. You cannot reproduce the same test in on-street level conditions. Increase calibration effort for all vehicle and powertrain variants. And only simulation can cover the infinitely many variables of RDE. So the RDE solution is trying to connect all the environments of the process of calibration. So that thing being said, I'd like to conclude my presentation, and I'm open for questions and answers. And I expect to to be able to answer all of your questions.
Muchas gracias, Guillem. Bueno, entonces abrimos la sesión de preguntas. Entonces, vamos a iniciar con las preguntas aquí por el chat. José Ignacio tiene algunas inquietudes, entonces adelante.
Hay un interés creciente de medir las emisiones de las motos, pero motos que se están usando ahora para tipo mototaxi o mototriciclos,
Sí.
motos en general. ¿Ustedes tienen algo en particular para determinar las emisiones en ese tipo de vehículos?
Otherwise, I need to use my Portuñol. So, regarding this, we have it's a little, how can I start to do this? Because for this kind of solution, we are trying to develop a simpler equipment for two road topics. I can try to give you more details later if you want it.
Okay.
Okay. But as far as I know, I don't know. One thing it would be possible to use, and there are also some kind of discussions, the possibility to use kind of a trailer attached to the motorcycle to make also these measurements, or using a laboratory test, use the PEMS attached. Mm-hmm.
La siguiente pregunta son más rudas. Sabemos que en el uso de PEMS un aspecto crítico es la sincronización de datos. Esto es algo que genera muchos conflictos, muchos problemas. Nosotros hemos usado PEMS y pues finalmente lo hacemos nosotros mismos. Sé que las empresas fabricantes están tratando de resolver ese problema. ¿Nos quiere contar cómo lo hacen para que el usuario no se enfrente a ese problema?
Sí. For us, it's very simple because we have the system control, which will be the PC, right? The computer that will be in the vehicle, gathering all this data coming from the PEMS, the gas PEMS analyzer, the HEC module, the exhaust flow meter, or other modules. So we're gonna have all this data, okay, in the system control. Also regarding, we have the GPS, temperature, pressure, humidity relative, and also the OBD2 signals from the vehicle. So with all this data, we take all this data and move to our post-processing software. In this post-process software, we can do all this time alignment on the software. It's really easy, so it's also really user-friendly. So with our software, you can do all this synchronization of the data and run the report without any issue.
Okay.
So at the end, we're gonna have, you see, now, I don't know if you can see my screen.
Yeah.
Are you still seeing my screen? Okay.
Yes.
So we have here the system control, all the modules come here, and all this data comes to the software. The software do all this data synchronization. And at the end, we're gonna have something like I showed to you in the test that we did here in Brazil. So we're gonna have this. So we have here all the data coming from the vehicle, all the other modules. So everything is reunited here.
Okay. So
I'm also responsible for this software. In another moment, I can show you really quickly how I can use a test demo, how to generate this kind of report. You're gonna see that after you have all the parameters from the vehicle or the parameters regarding the fuel or legislation, it's really easy to make the report.
Okay, but then the question is a little bit more, let's say, we would like to know what is the technique that you use in that model or in that software to do that time alignment. Can you,
Okay, so
do you have any short answers for that, or is
yeah,
better to discuss it?
yes, there is no short answer for that because it's our in-house solution. So different suppliers and different competitors do in different ways. But we as AVL, we use with the software, we can, let's say, work in this data and synchronize all of them. It doesn't matter. Also, if you have a video that you recorded during all the tests, you can synchronize with all the instantaneous emissions, variation of speed. So for example, in the time 2000 seconds of the test, you have a pike of emission. Okay, you want to see why this is happening. So you can see through the video. You can see, I don't know, you can see how aggressive the driver was, or there was a truck, I don't know, in the highway that the driver needed to take over. So you can see everything. So with this software, with this in-house solution, all the time, all the parameters are synchronized. We do automatically the time alignment.
My last question is about the measurements of NOx. NOx.
Okay.
I found out recently that vehicles report, some diesel vehicles report NOx measurements. Do you know how those measurements are taken, and what is your opinion about those measurements? Not with your technique, but using the engine computer, the ECN or via OBD.
Okay, I guess for this question, I'm gonna I'm gonna take as a homework and try to answer you later, because to be honest, I'm not the best person to discuss with you which kind of calibration strategies, ECU strategies we are seen to be the best ones regarding NOx emissions or other like THC or CO2. So it'll be okay if I can take this question of you.
Yes, for sure.
And try to have a better answer for that.
For sure, thank you.
Okay, I appreciate it.
Thank you.
Thank you.
Okay, muchas gracias, listo. Y ahora le vamos a dar la palabra a Felipe. Felipe, adelante.
Hola, buenos días para todos.
Buenos días.
Hola.
Bueno, inicialmente agradecerle a Guillem por la presentación y tengo dos preguntas. La primera es acerca del uso del PEMS en temas normativos. Entonces, solo quisiera en esta primera pregunta verificar si el PEMS actualmente es utilizado para medir emisiones de CO2 de CO y de NOx, o si también es utilizado para medir CO2 dentro del marco normativo, dentro de las políticas de control de emisiones. Si quieres,
Okay.
Mi primera pregunta y ahorita hago la segunda.
See, I can answer this really fast. Yes, our equipment is using to measure all the requirements from the legislation. If we were talking about NOx, THC, CO, CO2, for example, here in Brazil, going the other way around of the other regions of the world, like Europe, they are aiming with particle number, NOx, CO, CO2. Here in Brazil, we're gonna also measure, our legislation will measure also the THC. So our equipment is ready for this kind of measurements.
Ok, gracias.
Okay.
La segunda pregunta que tenía es relacionada con si existe alguna restricción respecto al tipo de vehículo o a la tecnología del vehículo en la que podamos utilizar el PEMS. Es decir, si existe alguna restricción por, digamos, puede ser un vehículo muy antiguo o tiene que tener, puede utilizarse solamente con vehículos que tengan acceso a través del puerto OBD. ¿Existe alguna restricción tecnológica de en qué vehículos podemos utilizar PEMS?
Uh, let's try to uh, let's try to go this way. So regarding really old vehicles, we just need to keep in mind that the connection regarding the OBD will be a problem, right? So you need to find a way how to do the communication between our equipment and the vehicle. But when we are talking about development purposes, I don't see any restriction only regarding the OBD communication. But if you have an alternative of using that, as I mentioned, our solution is really flexible. So if there is a COM port or serial port, we can communicate. We can do this communication with our PC that will be in the vehicle and try to get all this data and generate all the required data to have a test. Did I answer your question?
Yes, you did it. Thank you very much.
Okay. You're welcome.
Ok, muchas gracias. Y dado que nos quedan unos minutos más, abro el espacio si hay alguna otra persona que tenga alguna inquietud.
But just also make another comment. I'm
Claro.
going to share with you this presentation. I guess you are seeing also my screen. So you can see there's a lot of other slides that I didn't show to you because otherwise it's going to be really long presentation. And I have way more material regarding this. So please feel free to contact me anytime. Here in Brazil or around the world, we as AVL, we have a lot of expertise and regarding emissions and calibration, and we can try to support you in some way to achieve your goals regarding research or development or to fulfill our legislation requirement. Doesn't matter.
Ok, muy bien, muchas gracias. Yo aprovecho y hago una pregunta. ¿Cuál es el precio típico de este tipo de tecnología?
So normally around this, if you are thinking about Brazil, so we need to have the gas PEMS to measure the CO, CO2, NO2, and also you need the THC model. So it's the FID, so it's the third model here. And also we need the exhaust flow meter to measure all the exhaust flow, right? So this equipment, so this setup with all the PC that will be in the vehicle, with all the GPS sensor, also the weather sensor that will measure the temperature, pressure, the humidity of the air. We are thinking and also the software to make the reports. We think around 250,000 euro.
Okay.
Okay, this is the price. This is the price of the equipment to be available in our headquarters in Austria. Okay, you need to consider the importation process also.
Ok, muy bien, muchas gracias. Creo que con esto cerramos entonces la conferencia del día de hoy. Muchas gracias, Guillermo, por tu tiempo, por tu presentación. Seguramente varios de nosotros te estaremos contactando para tener más detalles. Y muchas gracias a todas las personas que nos acompañaron el día de hoy.